In the video before this, we saw what ANOVA simply means and some definition of terms on ANOVA. Now I want to go into one-way ANOVA. We want to see what one-way ANOVA is all about. Now, this video will be in two parts. What one-way ANOVA is all about, and the next one, calculation under it. Okay? Now, one-way ANOVA has a model. A popular model that it is known with. That model is written this way. This simply means jet observation taken under height treatment. Then overall mean plus effect of eye treatment plus random error. This is jet observation taken under eye treatment. Please, treatment TRT. Then this is overall mean. This means effect of eye treatment. Why this one means random error. So, while trying to compute a particular observation using one-way ANOVA, you must take cognizance of random error because there could be error in analyzing this. So, you must take cognizance of random error. Then, this one-way ANOVA has assumption, three assumptions. The three assumptions are: 1, constant variance; 2, normality; and 3, independence. So note these three assumptions of one-way ANOVA. Okay? Now, we have been able to see what the assumptions are and the model. This one-way ANOVA has a table that we call one-way ANOVA table. And look at what makes this up. The table, the first one is source of variation. Then the next one is degree of freedom. The next one is sum of squares. The next one, mean of squares. While the next one is F ratio. This F ratio is gotten from a scientist named called Fishner, who also made impact in discovering or in bringing this topic ANOVA to us. Okay, so the F is gotten from the initial of Fishner, F ratio. Okay, so in one-way ANOVA, we want to see what makes it up. 1 is between treatment. Next one is within treatment. The next one is total. Under between treatment, we have K minus 1 to be the degree of freedom. Then we have M minus K to be the one of within treatment. And we have M minus 1. It means that this plus this will give you M minus 1. Sum of squares, we will be having sum of squares of the treatment, sum of squares of the error, then sum of squares of the total. That means that sum of squares of the treatment plus sum of squares of the error will be giving you sum of squares of total. That is what we have here. Okay? Mean of squares. Mean of squares mean this over this. SS treatment all over k minus 1 SS error all over n minus k. That is for within treatment. Okay? Then F ratio means what you get here, which we call MS treatment. MS treatment all over MS error. So we will be having one conclusion. Only one conclusion is what we have because we are discussing one-way ANOVA. If it is two-way ANOVA, we have two conclusions. But because we are dealing with one-way ANOVA, we will be having one conclusion. Remember that MS treatment means SS treatment divided by k minus 1. Also, MS error simply means SS error divided by n minus k. Okay? Now, we also need to know these formulas for us to be able to compute or solve any question on this. We also know that SS total is equal to summation of Yij. That's summation of jet observation taken under I treatment. Okay? Then all squared minus y squared all over n. Then SS error will now be giving us y. Let's start SS treatment first. SS treatment, the formula for it is all over n minus summation of yi squared all over n minus y squared all over capital N. Then the last one, since SS treatment plus SS error equals to SS total, that gives us that SS error will now be equals to summation of, when you minus this and this, you'll be having summation of Yij square under Ij, and then minus this minus summation of yi square all over n. Okay, so these are important formulas we need on this topic. We want to see calculation on this topic so that we'll see what to. We'll leave this table here as we solve the calculation. See us in the next video.